All right, here we go. Unit 3, Day 1, sine and cosine derivatives. And we're going to look at what these derivatives are by examining the functions for sine and cosine along with the unit circle to just kind of intuit how would we find the derivatives of the sine and cosine functions. The result ends up being pretty neat. So here we go. We're just going to fill out this table starting with what is going on with each of these functions at negative pi. So I'm going to examine the red function, which is sine of x, and the blue function, which is cosine of x, and answer these questions. So the first question is just what is the sine of x when x is negative pi? So the sine of negative pi, as I can tell from my graph here or thinking about the unit circle, the sine of negative pi is 0. The next question is what is the derivative? Remember, the derivative is the slope of the tangent line to sine of x at negative pi. So I'm going to draw sort of a tangent line here or close to it, and I'm just going to estimate, I'm going to say that that looks like a slope of -1. That looks like the slope of the sine curve at negative pi is -1. So now we'll go on to the cosine function. The cosine of negative pi, either from looking at this or knowing your unit circle, the cosine of negative pi is -1. And the derivative, the slope of the tangent line to that cosine function, is 0. So we're going to fill out the rest of this table pretty quickly. If we have the sine of negative pi over 2, the sine of negative pi over 2 is in fact, wrong graph. The sine of negative pi over 2 is -1. The slope of the tangent line is going to be 0. And then for the cosine graph, cosine of negative pi over 2 is 0. And the slope of the tangent line is +1. We're going to start to see a pattern emerge. When we look at 0, the sine of 0 is 0. The slope of the sine function, f prime of x, is +1. And now when we look at the cosine function, the cosine of 1 is 1. And the slope, the derivative of the cosine function, is 0. Pattern is starting to emerge here. We've got 2 more just to fill out, and then we'll reveal what the pattern is. Sine of pi over 2 is 1, and the slope of the sine function at pi over 2, f prime of sine of x, is 0 at pi over 2. Looking at the cosine function, the cosine of pi over 2 is 0, slope of the tangent line, -1. Last one here just to make sure that what's going on is actually happening. The sine of pi is 0, slope of the tangent line is -1, cosine of pi is -1, and the slope of the tangent line is 0. And so there are 2 rules that you need to commit to memory that this table hopefully gave you enough proof of. We can do a bigger proof of it later. But the first pattern, the one that is sort of the quickest to notice here, is this one. Notice all of these are the same. So the slope of the sine curve at any given point in time is the output of the cosine function. That's pretty cool. The derivative of sine is cosine. That's just like a pretty wild fact that I'm not sure ever kind of like came up in pre-cal, but it's maybe something you could imagine like noticing on your own. Like, hey, the slope of the sine function is the cosine function. And so our first rule here is that the derivative of sine of x is just cosine of x. It's a pretty cool fact. The derivative of the sine function is the cosine function. Now the other pattern is a little trickier to see, but just it's trickier to see because there's a negative involved here. But if you look at the derivative of the cosine function, all it is negative the sine function. So check out those 2 greens on the right here is the derivative of the cosine function. Notice it's just the sine function with the negative sign flipped. So the second thing that I need us to commit to memory is that the derivative of the cosine function, is negative sine of x. And these are two rules that are going to come up again and again and again and again. These are things that you need to commit to memory. We're going to get a lot of practice with them today with the product rule. The derivative of sine is cosine. The derivative of cosine is negative sine. Jokingly last year, I would just confront people in the hallway and ask if they knew these two things. So those are two really important derivatives. Derivative of sine is cosine. Derivative of cosine is negative sine. And pretty much done with this video here. Just wanted to show just a couple of key things. We quickly went over this, but just remember, if I have just some generic function f of x and it has a coefficient out front, I can bring that coefficient out to the front and then take the derivative of what's left. So the derivative of 5f of x is the same thing as 5 times the derivative of f of x. What that means here is if I ask the derivative of 3 sine of x, well, it's just going to be 3 times the derivative of sine of x, which is cosine of x. If I ask for the derivative of 5 cosine of x, it's going to be 5 times the derivative of cosine, which is negative sine of x. And so we could clean that up a little bit. We could call this negative 5 sine of x. And so where these end up tripping people up is there's just like a lot of negatives to be careful of. So anytime, right, that you can break this up, okay, let's bring this negative 7 out, and you can write it as formally as you want. You could say this is negative 7 times the derivative of sine of x, okay? I know that's negative 7 cosine of x. And so it's just a matter of like how comfortable you are with these negative signs, but particularly when working with cosine, it can be helpful to say that this is negative 2 times the derivative of the cosine function, and that this is going to be negative 2 times negative sine of x, which is equal to 2 sine of x. And so that's it for derivatives of sine and cosine functions. Again, just super, super important that you commit to memory that the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. That's the tricky one to remember. Those are the two things to commit to memory on this.